Hello guys, so today we've just seen the cockpit media that is untreated. So what we have here is cockpit that is being treated. Now for our cockpit, what we usually do in treating, we usually take the cockpit and mix it with water. The water is usually a solution. It's a solution of calcium nitrate. Now what we have here is calcium nitrate. We make a solution of calcium nitrate, then mix it with the cockpit and leave it to soak for a number of days. For example, let's say 3 to 4 days. So after mixing, we use this device here, which is an EC meter, to measure the salt, the salinity or the salt levels of the media. So we just insert it here and then be able to get our readings, so as to ensure that our media is ready for transplanting. In this next video, we are going to look at the IPM, meaning integrated pest management. We are going to look at the IPM methods that we usually undertake at our hydroponics. So come with me. So first of all, we have this known as double door method system. It is one of the ways of controlling pests and diseases. So the first method is the cultural method, and one of the cultural method is the double door system. Now the double door system is whereby you have two doors. Here we have the first door and the second door here. So how the system operates is that we need to have the first door need to be closed before the second is opened. So we are going, now that the first door is closed, we are going to open the second door and enter so as to prevent the entry of pests and diseases. Before we enter, we have a foot bath here. Now this foot bath is disinfected so as to prevent entry of diseases and pests. So we are going to dip our feet here so as to disinfect from diseases. So after that, we are going to wash our hands so as to disinfect our hands and avoid transmitting pests and diseases to our greenhouse. Okay, so that is the cultural method, where we have the double door entry system, the foot bath, and also washing our hands to ensure that we don't transmit diseases. Now that is the cultural method. On to the second method, we have the biological method of pest control. Now what we have here, we have sticky cards. Now these sticky cards, we apply the principle of biology. We use the biology of pests that we are trying to control. For example, okay, so here we have the yellow sticky card. Now the yellow sticky card attracts the whitefly, which is naturally or biologically attracted to the color yellow. So when the whitefly is attracted to the sticky card, it gets trapped, and in so doing, we are able to control the whitefly. Over there we have the blue sticky card. Now this blue sticky card attracts another type of pest, which is known as the thrip. Now unlike the whitefly, which is attracted to color yellow, the thrips are attracted to color blue. Now when the thrips get attracted to color blue, they also get stuck on this sticky card, and in so doing we are able to control our pests and diseases. Now that is the biological control method of controlling pests and diseases. We also have other methods, such as the use of biological predatory insects, for example the miracle and other wasps that control the tutor absoluta. Besides the use of sticky trap, we also have the use of tutor pan. Now this tutor pan contains a pheromone trap, which is this orange rubber, and on this pan we have water that has been mixed with soap. So when the tutor absoluta gets attracted to the pheromone trap, it will move within the pheromone, and in the process it will be trapped by the soapy water, and in so doing we are able to control our pests. Besides the use of the tutor pan, we also have this delta trap, which contains a sticky card and a pheromone trap. Now the principle is the same, where the insect will get attracted to the pheromones. The pheromones will emit the pheromones will attract the pest, and the pest, when gets attracted, it will move towards the where the pheromone trap is, and in so doing it will get stuck to the sticky card uh, which has the pheromones. The second method that we use to control pests and diseases is known as the mechanical method. Now, with the mechanical method, we physically pinch out affected areas of the plant. So, for example, with our leaf here, we see that when we see that we have this pest here, which is the leaf miner. So we are just going to pinch out the specific location of the leaf where the pest has been observed, and in so doing we are able to control the pests. Thank you. Today we are talking about nutrition, crop nutrition in hydroponic farming system. Hydroponics as a form of climate smart agriculture. So with me here is Damaris. She's an agronomist. She's my agronomist at the farm. Now she's going to take us through the nutrients that we usually use at the farm. So Damaris, thank you so much for joining us. So if you can tell us what is this?
Basically, in hydroponic we use the fertilizer that are made human made. It is not available in the soil, so it is just simple, and we supply the nutrients artificially to the crop through the mixing. And here with me is some of the nutrients that we normally use. We must supply the 17 elements to the crop that is supposed to help in the production and the photosynthesis as a whole process. So with me, I'm holding a mix of nutrients. I have the nitrates, as you can see. We have almost, it's about around 850 grams. Then I have the sulfates, the potassium sulfates and all that in 450 grams.
Record.
I also have the trace elements. I have the iron and all the trace elements combined here for around 200 ml of those combined elements. It is in liquid form so that it cannot cake and all that. So then after this, for this we call it tank A, tank B, then we have tank C as the acid now for regulation of pH. pH, I mean the potential hydrogen. Yes, so it should be at a range of between 5.5 and 6.3 for your plant to uptake all the nutrients needed for photosynthesis and production. Yes. With me, I have the gadget. It is called EC pH meter that is used to measure the alkalinity so as to feed at the range that I had advised earlier, between 5.5 and 6.3, so that the nutrients can be uptaken very well in a good conducive environment. So this is the EC. As you can see, it has also as you can see, yeah, we have the pH, we have the EC. Yes. So we will start with the mixing and direct you in how we do our mixing so that we can go to our crops early in the morning. Yes. Step 3, we have our micronutrients. We add now at the last part of the now this is the final solution after mixing all the nutrients. And for your crops now to be happy and to eat well and be satisfied, remember I told you the pH should range at 5.5 to 6.3. As you can see, mine is almost there. And also the EC, it should range from 1.5 to 2 EC so that it can be satisfied and full of the nutrients. And we recommend at the square meter of 1 square meter for the crops to be fully in order and to be well fed. Each crop should have been fed 2 grams of the nutrients. This is now our calculation now technically for you to supply the 2 grams to each crop daily. Yes.
Yeah, that's it, guys, on crop nutrition. Thank you for being with us. Thank you. Hi, guys. Today I'm here with my colleague Hannah Wangoi. She's going to talk about hydroponics, cultural management practices of hydroponically grown crops, because we know hydroponics is a form of climate smart agriculture. So Hannah, karibu sana. And what are some of the cultural methods of growing hydroponic crops?
So for cucumber,
Yes.
we have several cultural practices.
Mm-hmm.
Like we have leaf pruning, we have leaf pruning, we have fruit thinning,
Mm-hmm.
we have removal of suckers, we have lowering, and then we have pollination. So taking one by one, we start with leaf pruning.
Yes.
For leaf pruning, we remove excess leaves starting from the lower side.
Mm-hmm.
Which enhances aeration of air.
Yes.
So for good aeration of air. And for removal of suckers,
Mm-hmm.
if you look, you can see there are some leaves where the fruit is. You can see there are some leaves that are. So you remove them to enhance the growth of fruits.
Okay.
For fruit thinning, it's also for enhancing the growth of fruits and for the fruit to be bigger and to avoid competition of nutrients.
Mm-hmm.
So for lowering of the plant, you lower it for proper management. But because when it grows taller, you cannot manage it so you put it in a level where you can manage it.
Maybe the final method or rather cultural practice that we practice at the farm is harvesting. So as we can see, Hannah, tell us more about what type of cucumber is this?
This is a local cucumber, which is Midas. It's a local cucumber. It's called Midas. Yeah. So this is my third harvest, and as you can see, it is promising.
Today I'm presenting about climate smart agriculture, specifically agri-tech. And today with me is this IoT device, IoT meaning the Internet of Things in matters agricultural production. So what we have here is the IoT device, the Internet of Things. So what we have here is a temperature and moisture sensor. So when I plug it into our media, we are able to receive the readings, real-time readings of temperature and moisture content of our media. Besides that, the IoT device also gives us real-time readings of the temperature and the light intensity of our greenhouse. And so as you can see, we have a temperature of around 21.4 degrees and humidity of 78. Now, the other thing about the IoT, the Internet of Things device, is that here we have a light sensor, so we can also get the light readings of the light intensity in our greenhouse. Now, the beauty with our system is that besides, in addition to getting the readings on the monitor, we are also able to get the readings on our phone. So it means that even when we are far from the farm, we are able to get the real-time readings of the not only greenhouse but even in the open field setting. So with this, we are able to get alerts via the software and through SMS and also via email. So it means that even when one is as far as even in the USA or somewhere in Europe, we are able to get the real-time readings which gives the business person the position to be able to change the temperature and light settings so that the crops can grow in optimum conditions. Thank you. Now today here at the farm, we are joined with Virginia Ngoiri, who is the chairperson for safeguarding at the farm. Now, Virginia, if you can tell us, what is safeguarding? Now, today here at the farm, we are joined with Virginia Ngoiri, who is the chairperson for safeguarding at the farm. Now, Virginia, if you can tell us, what is safeguarding?
So hi guys, as you've heard, my name is Virginia Ngoiri and I'm the safeguarding chairperson at the farm. And safeguarding is a department at the farm that deals with the welfare of the farmers.
Thank you, Virginia.
Yes.
Now, maybe at this point, Virginia can list for us some of the initiatives that the safeguarding office has conducted in line with the agenda for climate resilience and climate change. So, Virginia, at this point, maybe you can list for us the initiatives that the safeguarding office has conducted in relation to the climate agenda.
Yes, thank you, Newton. We have had a couple of initiatives at the farm by the department. One of the initiatives being planting of trees. Recently, we planted about 500 trees in a local primary school, and we believe that that is in line with what the government is trying to do in matters climate change. We have also championed for use of biological methods in pest management. Instead of using chemicals, we look at chemicals as our last option. And when we use chemicals, we try as much as possible to return the cans to the manufacturers instead of burning them. We have also been able to conduct a few trainings to the farmers and also the people at the farm in matters health hazard. We have also been able to conduct more trainings, Newton, in terms of pre-entry intervals and PHI when it comes to harvest. And yes, Newton, those are some of the things we've been able to do at the farm.
Thank you, Virginia. In addition to what Virginia has mentioned, we've also conducted GMBS training, meaning Gender Makes Business Sense trainings at the farm, which are aimed at ensuring that we have an equal society. We are advocating for equality in hydroponics as a form of climate-smart agriculture. So that is what we had for today. So today we have this initiative that takes advantage of plastic waste. So what we do, we recycle plastic bottles and use that to make a mini hydroponic kitchen garden. So as you can see, we have bottles that were once disposed, but we took them up from the dustbin and made the structure that we have here. So all these are bottles that have been cut so as to fit into our system. So what we have here is work in progress, and as you can see, we are through with the first stage. So we'll be showing you the next way forward after making this structure. So the next step forward will be on seed propagation. So the importance of this initiative is that apart from climate resilience, the advantage of this system is that it can be practiced even in areas where land is a limiting factor. So it can be used even in urban farming, for example in kitchen gardens, rooftops, and even on balconies. And so it is a good method of even saving the amount of cash that will be spent on buying vegetables such as coriander and onions. So it is threefold: first, food security, climate change, and finally economic empowerment.
Now we move on to the Young Africa Works Enterprise Management System. We first log in. After logging in, we get a summary of the sales versus costs of running various greenhouses. Also on the system, we can track individual greenhouse performance. For example, we can click on top up growers and see the start date and completion dates for the production cycles. Also, we can get the tasks, various tasks for operating the greenhouses, and see their completion status. For example, from transplanting, weeding, and up to trellising. Besides that, we can also get a summary of the greenhouse operation. In addition to that, we can also get the stock entry for various inputs and also the various entries for outputs. As we can see, we have tomatoes in the system. That is the stock entry for the output. And as now we can see the entry for various inputs and also outputs. As we can see, we also have cucumbers and the sales invoice for cucumber. Besides that, we can get total revenues arising from the sale of produce. As we can see, we also have a platform where we can see the individual greenhouses. For example, we have top-up growth, and we can see the start date and the end date for the production cycle of that greenhouse.
We also have the timesheet where we can plan, plan for the production operations, and as we can see that the production operations can be placed onto the task to assist with the easier tracking of production activities. That is all we had on the Young Africa Works Management Information System. Thank you. Okay, we've seen hydroponics as a form of climate smart agriculture. Now, part of our products that we take to the urban markets, we take them to retailers and also wholesalers. Now, those products sometimes, not all of them are bought, and the retailers and wholesalers face the challenge of damaged or rather rejected tomatoes, and those tomatoes which get rejected become an environmental hazard, which produce a not so good stench to the environment. Now, to counteract that, we've come up with the BSF, the black soldier fly, as a form of mitigating all that. So BSF is a common fly that undergoes the life cycle from egg, larva, pupa, and finally to adult. Now, we take the egg for the black soldier fly and introduce it to the waste, to the damaged fruits and other kitchen waste. We introduce the egg to that, and then the eggs slowly consume the waste, and in so doing they undergo their final life cycle, which enables them to reach from the egg, larva, and finally to the pupal stage. Now, after the 5th instar, we have different byproducts of the BSF, which are of benefit to everyone, from farmers and even to commercial proprietors. For example, we have the 5th instar of the BSF can be dried and packed for sale to chicken farmers as a form of chicken feed, which is very rich in proteins. Besides that, the larva can also be squeezed to extract BSF oil, which is of benefit to dairy cows. Because of its high protein content, it can be fed just the way molasses are fed to cows, and in so doing we are able to achieve a very high milk quality by the cows. And the final product of the BSF is the compost, which packed and sold to farmers, which has very rich nutrients and aids in soil fertility.